Hey guys, let's see. This is page 273 in section 3.5. We're going to keep going here. So now we're going to start putting all the techniques together. So first, let's just note what are the general steps for solving linear equations. So here are the steps. You might want to pause the video to write them down. This looks very similar to actually what we talked about with solving equations. If you flip a few pages back, you'll see that we have an almost identical list. So what I'm trying to get at here is you basically know how to do this already. You've kind of been doing it, just now we're going to be doing it with inequality, so it's got just a little bit of a twist on it. So let's go down and do a couple of examples. So go ahead and write these two down, and I'm going to walk you through how to do them. So for the first one, so you probably already have a sense of kind of how to do this. For A, you want to collect your like terms. So you're going to have this 5 minus 2x. That's 3x. So this side will become 3x minus 3. And that's still going to be greater than or equal to negative 12. Okay, so now I have to get the 3x by itself, right? So to do that, I'm going to go ahead and add 3 to each side. So I get 3x is greater than or equal to negative 9. Now to finish this off, if I divide both sides by 3, 3 is a positive number, so I don't have to flip the inequality. So this is going to be x is greater than or equal to negative 3. Now you also need to put your final answer on the number line and in interval notation. So here's my number line, and then here's my interval notation. Okay, so this one I think will go a little bit smoothly for a lot of you if you felt good with equations, and if not, then you'll probably get pretty good at them by watching this or by doing this section. Now, this is what do we do with three-part inequalities, so this can be a little bit tricky. So what I want you to do for a second is just pretend that we only have maybe like this part. Pretend that that 5's not there. How would you solve this? Well, you would start by subtracting 1. So that's actually exactly what you need to do. But instead of subtracting 1 now just from one side, you need to subtract 1 from all three sides. That's really it. Now you just do everything to all sides. So this becomes 4 is less than 2x, which is less than or equal to 8. And then I'll just divide everything by 2. So I get 2 is less than x, which is less than or equal to 4. And so then let's just put in the number line and the interval notation. So I'll do an open dot and a closed dot here, and then I'll just shade in between, and then this goes from 2 to 4. Okay, so what I want to do then on the next page is just give you a few more examples like this, and of course you'll have plenty of practice with this in your homework as well, but let's just do a few of these to make sure that we've got it. So to begin, why don't you try this one here with a three-part inequality? Just hit play when you're ready. So I'm going to go ahead and subtract the 2 from all sides so that I get negative 6 is less than or equal to 3x, which is less than 9. Then I'm going to divide all sides by 3, so I get negative 2 is less than or equal to x, which is less than 3. And so then you just have to fill in your number line. So let's see, I have a square bracket at negative 2, I have a round bracket at 3, and here's my interval notation. Okay, so there's one. So I think we've got the idea of kind of working with those, so let's take a look at some other examples. Okay, so I've got another example here for you. So you can go ahead and hit play when you are ready to see the solution. Try it by yourself. So first things first, I've got to distribute. So this is going to be 6x plus 15 minus 12 minus 8x is less than or equal to 7. So a pro tip here, just make sure that you distributed that negative 4. So this is negative 12 plus 8x. So just double check that you did that. Okay, so now I need to collect my like terms. So 6x minus 8x is going to be negative 2x. And then 15 minus 12 is going to be 3. So here's what I'm left with, and now I can subtract the 3, so I get negative 2x is less than or equal to 4. Now, if I divide both sides by -2, I get that. So just notice, right? So this is a negative number that I am dividing by. So if I divide both sides by a negative, now my inequality has to flip. So this is going to be x is greater than -2. And then we'll just drop that number line right here with the closed dot. And here's my interval notation. Okay, so let's take a look at some with fractions and decimals. Okay, well, you probably predicted that this was going to be coming. So now I've got a 3-part inequality with fractions. Well, think about what we do with fractions in general. In general, we want to clear out the fractions, and that is still the same principle here. So the question is, what is my LCD of all fractions? In this case, it would be 10, right? So just like you would with an equation, what you want to do is you want to multiply each part of this problem by 10. So it literally works the same as before, as what we did in another video. So I'm going to leave you guys to this. Go ahead and try it on your own. Hit play when you're ready. So as I work through this, so 10 goes into 10 once. So 1 times 3 is, or 10, yeah, 1 times 3 is just 3. Now 5 goes into 10 twice. So 2 times 1 is going to give me 2. And then 2 goes into 10 5 times. So 5 times 1x is going to give me 5x. And then 5 goes into 10 twice. So 6 times 2 is 12. So there's what I'm left with. And so now I can just proceed as usual. So I'll go ahead and I'll subtract off the 2. So I get 1 is less than 5x, which is less than 10. Divide all sides by 5. And that's really it, right? 1/5 is less than x, which is less than 2. And so I'll just write out what my number line and my interval notation look like. So those both have open dots, and then I go from 1/5 to 2 as shown. Okay, so let's do one more with fractions, and then we'll pivot to decimals. Okay, so I have one more with fractions, and if you're just totally lost on how to do this, so we talked about this in section 3.2, and this was specifically discussed on page 246. So if you want to go back and just watch the technique there, I explained it in a lot more detail, so I'm assuming on this page that you've mastered it, but if you have to go back and review, that's totally fine. Okay, so remember, with this, the idea is that you want to find the LCD of all the fractions that you see. So here, my LCD of all the fractions is going to be 6, and so I just have to multiply. Remember, we talked about each part. So this is a part, this is a part, and this is a part. So I'm going to multiply each one of those by 6. And let me get rid of these lines here. And I just have to multiply one part of it, right? And I don't have to worry about multiplying inside the parentheses. So if I go through this, 3 goes into 6 twice. So this is going to leave me with 2. And then 2 goes into 6 3 times. So I'm left with this. And then 3 goes into 6 twice. So this is going to be 2 times x minus 3. So like I said, if this just feels like something you just have no idea what I'm talking about, highly recommend that you just look back in the videos here. And I go through the whole technique and I break it all down for you. Okay, so now I can go ahead and distribute. So this is 4x minus 10 minus 3x plus 24. Make sure that you properly distributed that 3. And this is going to be less than or equal to 2x plus, I can't do math. Okay. All right, 2x minus 6. Okay, so now I can go ahead and collect my like terms. So 4x minus 3x, this is x plus 14 is less than 2x minus 6. Now, as a personal preference, I prefer having my x's on this side. but I just want to show you something that could happen and just how to deal with it. So let's say I decide to subtract my x over to here. So now I've got 14 is less than x minus 6, and then I add the 6 to both sides. So now I get 20 is less than x. So this can just be a little bit awkward to look at. So you might want to just flip this so that the x is on the other side. And I always think of this, I know this is like so silly that I'm a math teacher, but I still think of this, but I always think of this as the mouth of the inequality, whichever way it opens, it's got to still go in the same direction, right? So that's the way I always think about it, which I know is kind of silly. Anyways, so now if I do my interval notation and number line, so let's see, I have my 20 here, I've got an open dot, and there's my interval notation, so I'm good to go. Okay, so I just want to do one more example just with decimals, just as a quick refresher on that, and then we'll be good on this video. So let me give you one more example. Okay, so just one last refresher on this. So now I've got all my decimals, and we talked about this also in 3.2. So if you have no idea how to clear decimals, you can watch the video on that. This was from 3.2, and you'd want to look up the stuff from page 347, or 247, sorry, my bad. So you can just reference that if you have no idea what I'm talking about. But just as a quick reminder on this, so to move the decimals, so remember, you just count the maximum number of decimals. In this case, it would be 2. And then you move each decimal that maximum number of spots. So if there's an empty spot, then you put a 0 there. And then you just proceed as usual. So this becomes 6 minus 2x is greater than 10. So now I can go ahead and subtract 6 from each side. I've got negative 2x is greater than 4. Now when I divide by the negative, I have to flip my inequality. And then I get this for my number line, and I get this for my interval notation. Okay, so I think that's a pretty good list of problems. So in the next section, we're going to talk about just a couple of applications and word problems and all that, and then we'll be done with this section. So I'll see you guys in the next video. Thanks!